All right, welcome to the Explainer. Today we are firing up the engine that really powers modern big data, Apache Spark. In just the next few minutes, you're going to understand not just what it is, but how it thinks. And, why it's become this absolutely essential tool for making sense of just massive amounts of information. This question really gets to the core of the problem, right? We're drowning in data. It's so easy to collect. Every click, every single transaction, every sensor reading, it's all getting stored somewhere. But actually using it? Well, that's a whole different story. The sheer volume of information can turn what seems like a simple question into a massive, massive computational headache.
And that's the core problem, right there. The software tools we've been using for decades, they were just designed for a totally different era. They weren't built to run a single job across hundreds or even thousands of computers all at the same time. So to solve this, we didn't just need a faster tool, we needed a completely new way of thinking, a new programming model.
So let's talk about the big data problem. This is what the whole industry calls it. And look, it's not a storage problem anymore. It's a processing problem. The real question is, how do you work with a data set that's just too big to fit on one machine, or 10, or even 100 machines, and still get an answer back in a reasonable amount of time?
It's kind of like trying to empty an entire ocean with a single bucket. Your traditional tools, they're the bucket. And they're great for, say, a swimming pool, but they're completely useless against an ocean of data. You need a new system, one that's designed from the ground up for massive parallel work. And that gap, that's exactly where this new kind of engine was needed.
Which brings us to Spark, a truly unified engine. See, Spark wasn't just a small improvement on old ideas. It was a completely new design. The whole goal was to create a single, unified engine that was capable of handling pretty much any large-scale data task you could possibly throw at it.
So here's the official definition. Apache Spark is a unified analytics engine for large-scale data processing with a really efficient in-memory engine. Now the key phrase here is unified engine. Instead of having to juggle a bunch of different tools for different jobs, Spark gives you one single platform. And its secret weapon? It's all about how it uses memory. Older systems, like the original Hadoop, they had to constantly write all their intermediate results to slow hard drives between each step. Spark, on the other hand, does as much as it possibly can in memory, which makes it just orders of magnitude faster. It's a total game changer.
Okay, so how does Spark actually think? How does it get all this speed and flexibility? Well, the real magic isn't in the hardware, it's in its approach. Before it even touches a single byte of your data, Spark creates a complete optimized plan. Let's walk through a super simple example to see what that really means in practice.
So imagine we've got this data set of online retail sales. It's pretty standard stuff, right? You've got invoice numbers, product descriptions, how many were bought, and the country of sale. And let's say our goal is simple. We just want to find all the sales that happened in the United Kingdom. Now, the Spark workflow really boils down to two main ideas. First, you build a plan. You do this by defining a series of what are called transformations. This is where you load the data and then tell Spark what you want to do with it, like, hey, filter for all sales in the United Kingdom. Then, and this is the important part, only then do you call an action. An action is what tells Spark, okay, go execute that plan and give me a result, like maybe a count of all those sales.
And this separation, this split between planning and executing is literally the most important concept you need to understand about Spark. It's called lazy evaluation, and it's the absolute key to its efficiency. The perfect way to think about this is like writing a recipe.
So a transformation is just a step in your recipe. It's an instruction. You might tell Spark, okay, first, filter for UK sales. Then you might add another step. Next, group the results by product. And then maybe, finally, sort them by quantity. You're building this logical plan, but here is the key. Spark hasn't actually touched a single row of data yet. It's just taking notes on what you want to do.
Then comes the action. An action is the command to start cooking. When you ask for a final result with a command like count or save, that's when Spark looks at your entire recipe all at once. And because it waited, it can optimize the whole plan. It might realize, hey, I can filter the data before I sort it, and that'll save a huge amount of work. It then executes this super optimized plan across all the machines to give you the final dish. This wait, plan, then execute approach, that's the core of its incredible efficiency.
All right, so now we have the building blocks, right? Transformations and actions. But the real power of Spark is how this simple model scales up to power everything from basic reports all the way to complex artificial intelligence.
Because yeah, that simple recipe model is the foundation, but what you can build with it is what's truly, truly impressive.
And this is where that unified promise really pays off. You can run SQL queries just like a database. You can train complex machine learning models. You can process real-time data as it's streaming in. You can even analyze complex networks with graph analytics. And you're doing all of this using the same underlying engine. No more stitching together 4 different incompatible systems. It's all in one place.
Okay, so let's bring it all home. When you look at the landscape of big data today, why is it that Spark is the name you hear over and over? Why does it dominate the conversation? Well, it really just comes down to 3 core advantages. It all boils down to these 3 things. First, it is ridiculously fast, and that's all thanks to that intelligent in-memory processing we talked about. Second, it's incredibly versatile. It's like a Swiss Army knife for data. It can handle everything from SQL to AI. And third, it's unified. It brings together your historical batch analysis and your live streaming data into one single coherent flow. And that combination, that's what makes it so unbelievably powerful.
So I'll just leave you with this thought. Apache Spark isn't just a piece of software, it's an enabler. It fundamentally changes the scale of the questions you're even able to ask of your data. So the real takeaway is this. What questions would you ask if you could analyze all of your data all at once?